Good day, everyone, and good day, Architect Christine Ferraris. My name is Patrick De Leon, and this is my presentation for our final exam requirements for housing. The topic is about designing resilient and climate-responsive housing in the Philippines, policy, design, and technology integration. Today, I'd like to introduce my proposed project for disaster-resilient housing in Barangay Banaba, located in San Mateo, Rizal. This area was selected due to its vulnerability to frequent typhoons and severe flooding, which have had devastating impacts on the community. Barangay Banaba sits near the Marikina River, a geographic location that makes it highly prone to flooding, especially during heavy rains and typhoons. In the past, the barangay has experienced catastrophic events such as Typhoon Ondoy in 2009, Typhoon Ulysses in 2020, and Typhoon Karina in 2024. These disasters submerged homes, displaced a lot of families, and claimed lives. The aftermath left the community struggling to rebuild, with many residents losing their homes and livelihoods. Given this recurring risk, it is critical to develop disaster-resilient housing in Barangay Banaba. Traditional structures in the area are often unable to withstand extreme weather, leaving families vulnerable year after year. By implementing resilient designs such as elevated foundations, flood-resistant materials, and reinforced structures, we can provide safer, more durable homes for residents. This project is not just about rebuilding, it's about empowering the community to face future disasters with greater security and stability. The importance of this initiative cannot be overstated. Resilient housing will save lives, reduce displacement, and ensure the families in Barangay Banaba are better prepared for the next typhoon or flood events. Moving on to policy and housing law analysis. Examining housing policies revealed important gaps. RA 7279 or the UDHA helps relocate families from danger zones, and BP 220 set basic construction standards. But both laws fall short in addressing modern climate risks. They don't require flood-resistant foundations or earthquake-proof designs. Critical protections needed in Barangay Banaba with its frequent floods and the proximity to the West Valley Fault. These laws focus mainly on affordability and basic shelter, leaving communities vulnerable to increasingly severe weather conditions. My proposal addresses this by incorporating essential resilient features like elevated structures and storm-proof materials that should be standard requirements. Now, let's delve into the proposed disaster-resilient housing design for Barangay Banaba, a solution meticulously crafted to address the community's unique challenges of flooding, typhoon-force winds, and extreme heat. At the focus of our design solution is an elevated structure, raised 2 meters above ground level on reinforced concrete stilts. This critical feature directly tackles Barangay Banaba's severe flooding history, where waters have risen as high as 2 meters during extreme events like Typhoon Ondoy and Ulysses. By lifting the living spaces above this danger zone, we ensure families remain safe and dry even during the worst floods. The concrete stilts are engineered with deep foundations to prevent undermining during prolonged flooding, while their slender profile minimizes water resistance to avoid structural stress from strong currents. Moving upward, the house itself employed CEB walls or compressed earth blocks with bracing systems, a strategic response to the typhoon-force winds that regularly batter the area. These interlocking supports create a rigid structural framework that prevents the house from twisting or collapsing under wind loads exceeding 200 km per hour, similar to what we experienced during Typhoon Ulysses. But resilience isn't just about surviving disasters, it's also about livability. The design incorporates passive cooling strategies to combat San Mateo's tropical heat without relying on energy-intensive air conditioning. The section drawing here shows how this works. The elevated design creates a natural airflow channel beneath the house, while strategically placed louvered windows and vented eaves promote cross-ventilation. The roof's steep pitch and overhang shade walls from direct sunlight, and the use of CEB walls and bamboo for the ceilings provide natural insulation. Together, these features maintain indoor temperature up to 5% cooler than conventional homes, a vital benefit during power outage after storms. For water management, the design integrated bioswales gardens into the landscape design. This gently sloped vegetation channels slows and filters stormwater runoff, reducing flood risks while recharging groundwater. Moving on to technology and NGO module integration. The project will be using a special building material called compressed earth blocks, or CEB in short. These blocks are made by mixing local soil with cement, then pressing them into strong bricks. Here's why they're perfect for this project. First, they're flood resistant. Even if floodwater rise, these sturdy blocks won't wash away like regular hollow blocks. They form the water of our elevated houses, staying dry above the flood level. Second, they keep homes naturally cool. The CEB walls absorb heat during the day and releases it at night, helping families stay comfortable without expensive air conditioning, especially important when power goes out after storms. Lastly, compressed earth blocks are affordable and community-friendly. The design can use soil from nearby areas, and local workers can learn to make the blocks using simple equipment. This creates jobs while keeping costs low. It is obvious in the design how these earth blocks walls work with the rest of the house. The roof protects them from the rain, and their thickness makes the whole structure stronger while maintaining comfortable temperatures. This simple but smart solution tackles flood, heat, and cost all at once, while giving the community ownership of the building process. It's traditional knowledge meeting modern resilience. Moving on to the site context of the proposed resilient housing project in Barangay Banaba, San Mateo, Rizal. Situated alongside Batasan-San Mateo Road, the site benefits from excellent connectivity to key urban amenities. Residents have convenient access to commercial hubs like SM City San Mateo and Pure Gold San Mateo, with various residential and commercial developments along General Luna Avenue. This urban integration ensures that the future occupants will maintain access to essential services, employment opportunities, and community facilities. However, these advantageous locations comes with significant environmental risks that demand careful considerations. The site's proximity to the Marikina River makes it highly vulnerable to extreme flooding during heavy rainfall, as tragically demonstrated during past typhoons like Ondoy, Ulysses, and Karina. Additionally, its position near the West Valley fault line, which introduces long-term seismic risks that could be triggered by a major earthquake event. Moving on to the plans and perspectives. The design compacts 6 by 6 meter homes that feel spacious yet safe. Each unit comfortably fits 4 to 5 family members with 2 bedrooms, a living area, a dining area, and a bathroom. The simple, replicable design allows for cluster development where multiple units can be arranged in various configurations to create vibrant community spaces while maintaining privacy. This modular approach enables us to scale the solution across the entire development while preserving neighborhood character. The architectural design concept blends modern Filipino design with disaster resilience. The combines sturdy concrete structures with warm wood accents and ample natural ventilation, creating a home that feels both contemporary and rooted in tropical tradition. These aren't just standalone houses, but an entire resilient community. 144 of these homes are arranged in clusters, sheltering 600 to 700 residents. The design blends modern concrete strength with traditional Filipino touch. Surrounding green spaces serves multiple purposes, absorbing floodwaters, community gardens, and safe play areas. This is housing designed for Filipino families where safety meets comfort and tradition meets innovation. Now for the materials. Starting with the walls, we're using compressed earth blocks, made from stabilized local soil at just 5 to 10 pesos per block. They're significantly more affordable than concrete hollow blocks while providing excellent thermal mass to naturally cool interiors, which is a crucial benefit in San Mateo's heat. The 5 to 10% cement stabilization makes them resistant to flood, ensuring structural integrity even during extreme weather. Above is a galvanized iron roof with bamboo matting underneath. This cost-effective combination does more than just shelter. The bamboo layer acts as natural insulation, reducing indoor temperatures while dampening the sound of heavy rains. Paired with hurricane straps, this system stays firmly anchored even during 250 km per hour typhoon winds. For windows, polycarbonate sheets offer shatterproof protections at half the cost of tempered glass. Their UV coating reduces the heat gain while maintaining visibility during storms. Below the elevated structure, permeable interlocking concrete pavers create stable ground cover that allows stormwater to drain naturally, preventing flood, pooling, and mosquito breeding, a common post-disaster health hazard. The 2-meter reinforced concrete stilts from the home's backbone, engineered to withstand Marikina River's flood, strong current, while preventing foundation erosion. Upstairs, treated bamboo flooring provides a lightweight yet durable surface that won't collapse if flooded, with borax treatment, protecting against Rizal's humid climate and termites. Lastly, for the reflection. This project taught me that building resilient housing isn't just about materials and designs. It is about people. While studying Barangay Banabas needs, I realized textbook solutions often miss real-world problems. The compressed earth blocks and bamboo solutions look good on this project, but I also learned their true value only when considering how families actually live with them. The biggest lesson is that resilience means nothing if communities don't embrace it. No matter how flood-proof our design were, they had to feel like home. Now, moving forward, I'll focus less on technical perfection and more on solutions people that can maintain. Because at its core, disaster resilience isn't about surviving storms. It's about preserving dignity through design. Thank you. That's all.